up with, we create an S. So this is like an integer and a VP with some random verb. For example, if we wanted to say that these two structures, when they combine, they need to be have agreement in like person or number. Say, for instance, the number is plural, and this verb would have to have the same thing, number equals plural, for it to unify up here. And so it's so if we didn't have the same value, or this one was underspecified, if we didn't have the same value, it wouldn't unify. But if this was underspecified, it would be able to be unified. And so you have different, this is kind of like the formalism of where you have the syntax and semantics in here, and these categories, kind of the syntax, and where the head value is a 3, and the content is this kind of the semantics section. And then you have the head daughter, which would be the VP right here. The head daughter has the phonetics of the left-hand side and the right-hand side, the head daughter, combined together, and these items. So the VP would have the matching head for the S. So this is kind of where the S lives. This is the VP, and this is the NP, right? And so if we thought of this as the S, because it's a head subject phrase, so this would be the subject, and then the head daughter, not head daughter. Does that make sense, kind of? It's kind of confusing, I guess. But it's just mapping the values from the lower branch trees up to the top with these kind of value, these box ones, the identity markers.
So it's essentially an alternative way of viewing a tree that has a lot of extra annotations on the nodes in the tree.
Right. Yeah. So these are the kind of how lexic phrases are structured. So you would have the top, and then you have your branches right here, the top node and your branches. But then a lexical item on the bottom would just have this, just have a phonetics and then a category.
So it's like a composition thing. So
Yeah.
As you go up, you fill in the slots.
Right. Like, yeah, it'll just be filling in, and then so like if we had this phrase in a bigger phrase, then this one would just attach into the head daughter slot right here. And so the whole sentence is this humongous matrix. Humongous. Yeah, and so that's kind of the basics of how HPSG is how it is representing the sentence. And so for this class, after learning HPSG, people in the class get to work on a new language and implement a new language in the HPSG formalism. And these are the 7 languages that we were working on. I reached out to Emily and I was like, Emily, I want to work on my language, please. This is why I'm taking the class. And she agreed with it, where normally she wouldn't, because she doesn't want people to really know too much about the language before going into the class. But I kind of was the exception for that, since hardly anyone knows about Yupik. And it's kind of a unique case. But the other ones were Abui, Jinkai, Matsugenka, Nuchan, which was on Vancouver Island, and Mumbai. And these ones were chosen because our year was kind of special, where we were going to have this other weird step where we can take kind of higher resources language. So all of these languages have a lot, not a lot, but like 200 different IGT sentences. You guys know what IGT is? Interlinear glass text. So you have the language, so you're gonna and then you're gonna have like dance, and then indicative, and then you're gonna have something here. He, she. So the languages that have a kind of a big corpus of IGT were used because we had this new step in the class. So the system is called LKB, and type feature structure is the word that is used for this kind of the AVM syntax. So type feature structure are in this Delphin software. So Delphin is kind of like the bigger organization, and then within this organization they have different software applications, and the LKB is part of their software stack, I think. And so we use this because it is able to unify these different things. And so if you created the AVM in this formalism called TDL, TDL is kind of like their code for creating AVMs, right? If you created the TDL code for each of these, then LKB will be able to unify it using just a bunch of composition of all of these different AVMs together. And if we had different things, then it would not accept this as a valid sentence.
So the unification is essentially the parsing.
Yeah, like parsing this whole sentence and then composing it and making sure it's a valid sentence in the language.
So do you have production rules as well, or just these feature structures?
So yeah, you're going to have lexical items, but then you're also going to have these rules. So this is called the subject head phrase, subject head phrase. And in Ubix, since we have variable word order, we're going to have a subject head phrase and a head subject phrase. So we're going to add both of these in to account for left-headedness or right-headedness. And so LKB is using Ubuntu, so it's in the Linux stack, and the easiest way for us was just have a VM with Ubuntu and LKB, and so we just download that and then run it on VirtualBox. So there are big grammars for this. So English and Japanese are kind of the two major ones using the LKB, and you can access them and use them and parse sentences using in this LKB software. Yeah, so the LKB is run inside of Emacs. They kind of just have a bunch of
It's the same with XLE. Like XLE you use
Yeah.
for LFG, which is like the exact same thing, and you have to do it in
Right,
Emacs.
right. I mean, you don't have to, but it's the easiest way to get access to everything, all of the functions quickly. And so
Is it written in Lisp?
Yeah.
I think it is. Yeah, I think it is.
Old school.
Yeah, you get the vibe of very old school.
Pretty sure that hasn't changed in 20 years or something.
Probably. So yeah, I talked about TDL, and LKB compiles those and is a parser and generator. But it also has exploration tools, like you can see the parse charts and see all of the different valid points where it's trying to parse. We can interactive unification, say we have this phrase right here, and we're trying to combine this NP and this VP together, and it should work, but it's not. So you can interactively unify these two and see which value has the error of like, oh, this one's a singular. You're trying to singular and plural are trying to occupy the same spot. So another thing that's was compatible with HPSG is called MRS, Minimal Recursion Semantics. This is the way that the semantics are represented in HPSG. It is using the same unification tools and mapping tools. And so you're going to have a semantics for this verb and a semantics for this noun. And all you're going to do is concatenate these two and link them up. Say the arg1, which is the subject, is going to map to the key of the noun. And so you're going to have your box 1 here and your box 1 here. And inside this rule, you're going to have the unification of those two, and it's going to map that noun to the arg1 of.
What does the sentence on the
Does that sentence
board
mean that the caribou and the woman are dancing together?
Yeah. So that was kind of the sentence we kept, because my partner, so we work on with pairs, 2 people on a language, and my lab partner, he was in California, and this was kind of the easiest sentences for him to like memorize. And so and it was a lot of the caribou is dancing, and and so so there exists a caribou, and there exists a woman, and they're coordinated. There exists the coordination of the caribou and the woman, and the arg1, which is mapped to arg0 of this coordination, is the subject of the dance relation. So the dancers are the coordination of the caribou and the woman.
What does hog and log mean?
Hog.
I'm just curious.
Which one?
It says hog and log.
Oh, H-arg and L-arg.
Yeah.
Yeah.
Do you know what that means?
I don't really understand.
Head argument and
Right.
L-arg?
So when the arg0 doesn't.
Lexical, maybe?
Yeah.
What's that?
Might be lexical argument.
The high and low.
Oh, high and low.
I think it's high and low. But these ones are mapping the existing with the caribou. It's kind of its own high construction.
So can you use this for generation as well as parsing?
Right, so this is the key for translation. You're going to map these, so you're going to have a sentence in this MRS, and then you're going to do some fiddling around with it, and then pass it to another language. And they're going to generate from this semantic MRS representation and output their sentences. Yeah. So there's the LKB, but there's also ACE, which is kind of the same thing, but this one is a lot faster. And so we use this for more of the generation and parsing of different languages together. As you can see, we compiled it, and then I gave it one sentence. The caribou and the woman are dancing, and then it kind of translates to itself in a sense. So it's gonna like fiddle with the semantics and then read it back in and generate from that. And so we get the woman and the caribou and their woman or his woman. Okay, yeah, their one woman they're dancing. Yeah, they're dancing. And so it's kind of like, if you didn't constrain the semantics correctly enough, or if it's ambiguous in Yupik, then it's going to output all these sentences.
So
And
it's
they're all
essentially
semantically correct.
paraphrasing.
Yeah.
What did you say, Lonny?
I said it's essentially paraphrasing, or generating
All the
generating
different.
alternative paraphrases that are consistent with the semantics.
Right, right. So with that same semantic space, if you can have, like in Yupik, we don't have definite and indefinite, so it's gonna have a dog, the dog, for every single option. So you're gonna have all of those.
Allowing Q as a standalone word.
That's how we analyzed it. It was the easiest way to say, oh, the and, it's the and marker by itself that it just attaches on.
Okay.
And it's semantically,
I mean, it's
Separate.
eclectic,
Yeah.
so.
yeah. But I wrote it up here as a shu, right? With
Right.
an equal shu.
Right.
It just ignores that. And it's kind of like how in the other language, or in other ways, the apostrophe S in English isn't really
Yeah.
analyzed that way. Yeah, it's kind of, apostrophe S is its own thing.
Question.
Yeah.
Could you try to explain, like, when it fills with the semantics, how does it know what to do? Sort of.
In generation.
Yeah, in generation. Like, when you give it the thing and it gets the semantics, and then you say fiddles with it.
Fiddles with it. Oh, so an example that we had to integrate was locative case. We had to change locative case to in Yupik, or in English. And so we had to kind of say, oh, if you have a noun and it's in the locative case, split up the semantics to say in this noun. And for English. Yeah. Yeah, so another software program that we used is this Inker TSP++. I guess those are pluses, plus plus. And this is for the test suite running. So we can load in our test suite of sentences, load in our grammar, and it'll just spit out all the sentences together. And as you can see on the bottom, I ran this one test corpus, and there are one reading or two readings of this sentence. So it parsed it into two different ambiguous sentences. And so that's how we did kind of our analytics.
So there's no morphology, right? It's word by word. Or,
There is a morphology. I'll talk about it later. Yeah. So how did we start with building a Yupik grammar? So the first step was to get this IGT. I had to manually edit Miyoka's IGT because it's not standard. It's so like all this parentheses P, I had to go in and delete these P's. He has brackets for like scopes, and I had to go in and delete that and like edit a bunch of stuff. And so I just took like 200 sentences, and it was good enough, I guess. And from that IGT, I gave it to them, and they pushed it through this aggregation. This is something they're working on currently, of taking this IGT representation, looking at the semantics from here and here, I guess, and trying to infer different semantic things about the language. So if we see like an NP in the nominative case, and then we see another NP in the accusative case, you can kind of infer that it's nominative accusative language. Or if you had something in ergative absolutive, then you know it's kind of an ergative absolutive language. And so you can just infer all of these. Another thing that it does is takes this word and it kind of breaks it, analyzes it as tetratic morphology, saying this is kind of the verb spot, and so it's going to put all the verbs in the verb spot. Or I think the first thing is it figure out what root morpheme is, right? It was having a lot of trouble, and we had to pretty much trash all of their analysis because it was saying the so both and then make and then indicative third singular. It was saying the make is the root, and it's saying, oh, this boat is an affix that attaches to the verb make, and that's not the correct interpretation in Yupik. And so we had she called it the rat's nest, and it was definitely a rat's nest, trying to untangle the rat's nest. Yeah, it was bad. So the corpus, the things she gave us from aggregation wasn't very helpful to Yupik because of that. But other languages that their verbs are just, they stay verbs, and then their nouns stay nouns, and that style, it worked pretty well for them, but not for us. And so we were given, from this inference, we were given a choices file, and from this choices file we can plug it into this, she calls it, it's the matrix customization system. So this is kind of a place where you can choose your options and then build your grammar, like a base grammar. And all of the core AVM stuff, so like we have, every language is gonna have a syntax and a semantics section. And so all of these kind of like things that are common to all languages that need to make the system run is all put into the core matrix library. But then this customization system, through your choices, will be able to pull in other libraries when, for instance, if it's a head final language, then we'll pull in all the head final rules, grammar rules, and different things like that. And what's going to be output is a well-formed grammar that's ready to be expanded. So it's not a toy grammar. It's ready to be however big as you want it to be. So from the inference, we got a bunch of these in blue. So we got word order, number, person, case, argument optionality, and then the big thing was the lexicon and the morphology. And the lexicon is the roots, the nouns and the verbs, and then the morphology is all of the affixes that are. And so this should, it should be possible that this can handle lexicon and morphology, but it's not to the extent of Yupik's morphology. So this is kind of like a diagram of the matrix website. So we have this website on the left. You can choose your question on the questionnaire, you can choose it, and then from the choices file, it validates it. If there are any errors in what you're choosing, then it goes back. And then from that customization system, it takes the core grammar to all languages, and then the stored length analysis from your choices file, and it gives a customized grammar. This was a 10-week class, and every week we had our pre-lab statistics. So we had our corpus and test suite coverage, and then we chose 2 or 3 phenomena to develop, worked on those, and then got post-lab statistics. So like from those sentences that we added in there, much did we get the phenomena correctly analyzed, and then more statistics of like, did you get more ambiguous or did you get less ambiguous with your sentences? And then we went back and forth with our lab person each week of, okay, he's doing the write-up, and then I'll correct it, and then next week I'll do the write-up, he'll correct it. And so this, for us, for UPIC, we worked on 2 or 3 each week. We went with the easiest ones at the beginning: case, argument, optionality, agreement, then negation, tense aspect, mood, and then we tried possession. Possession wasn't working because it was kind of a new library that someone worked on the previous year. Then we did causal complements, modifiers, evidentials, and then week 6 was kind of an interesting one where it wasn't part of the customization system. We were working directly in the code, TDL code, with blockative and MP predicatives, and then questions. Coordination was really hard, but through the help of Emily, we got it analyzed, and then finally, kind of like the last chance, we got possession working. And yeah, so at the end of this class, we do this MMT extravaganza, is what she calls it. Massively multilingual translation, where we took our 7 languages, plus English, plus a random one that a previous year had done, which was, and this was the previous year's PDSami.
Peter-Sami.
PDSami?
Peter-Sami.
PDSami. Yeah, and we were given these 29 different sentences that we had to get translations for first, and then kind of make sure they can parse. So that was a lot of work, and it was fun to like say, okay, or the next slide we have some of the sentences. So there are dogs, there are cats, there are some verbs, chase and sleep, and then we had to get all of these phenomena working. Can we have subjects? Can we have objects? And then negation, causal complements, another causal complements. We have coordination here, different kind of coordination. Or this was NP coordination. This is BP coordination. Or sentence coordination, BP coordination. Questions, adjectives, locatives, locative modifiers. Yeah, so just a bunch of different phenomena that we had to get working so that we can get these sentences parsing. Some questions, yeah, and so at the end of it, to get the translations working, we had to make sure generation was working first. Say from the semantics that we get, how many our sentences are being found, and then we have this variable property mapping. Say for instance, UPIC has a dual, and English doesn't, and so how do we get this dual mood to work when we translate to and from English? And so this is where the variable property mapping comes in. Let's say, okay, if you see a dual in UPIC, just output it to non-singular in English. And so those were mapped there, and then the last step was to get our transfer rules. Just the one transfer rule was the locative case that we had to do. And this was the final results. So we had a corpus of 217 sentences. We didn't touch them. We, like, the rat's nest, in the end, we just trashed the rat's nest of the inference of the corpus. And then we just worked on our test suite. We we got 144 sentences. A bunch of these sentences were not like negative, what's the word? Like, we had positive test cases and negative test cases. We want the negatives to fail. And then make sure, the goal was kind of just to get the average, the most items parsed with the least amount of ambiguity in the parses. Yeah. Yeah, so demo time. So we have the website. This website is publicly accessible. So she has all of her years there, so you can go in and see all of the different things that we used. All of the student-specific stuff was done in Canvas, and so you don't have access to that. Yeah, so the first step was the matrix customization page. We have a bunch of different things here. So we can choose some